The decisive act of Descartes, whose geometry appeared in 1637, consisted not in the introduction of a new method or idea in the domain of traditional geometry, as we are so frequently told, but in the definitive conception of a new number idea, which conception was expressed in the emancipation of geometry from servitude to the optically realizable constructions and to measured and measurable lines generally. With that, the analysis of the infinite became a fact. The rigid, so-called Cartesian system of coordinates, a semi-Euclidean method of ideally representing measurable magnitudes, had long been known, witness Orem, and regarded as of high importance, and when we get to the bottom of Descartes' thought, we find that what he did was not to round off the system, but to overcome it. Its last historic representative was Descartes' contemporary, Fermat. In place of the sensuous element of concrete lines and planes, the specific character of the classical feeling of bounds, there emerged the abstract, spatial, unclassical element of the point, which from then on was regarded as a group of coordered pure numbers. The idea of magnitude and of perceivable dimension derived from classical texts and Arabian traditions was destroyed and replaced by that of variable relation values between positions in space. It is not in general realized that this amounted to the supersession of geometry, which thenceforward enjoyed only a fictitious existence behind a facade of classical tradition. The word geometry has an inextensible Apollonian meaning, and from the time of Descartes, what is called the new geometry is made up in part of synthetic work upon the position of points in a space which is no longer necessarily three-dimensional, a manifold of points, and in part of analysis in which numbers are defined through point positions in space. And this replacement of lengths by positions carries with it a purely spatial and no longer a material conception of extension. The clearest example of this destruction of the inherited optical finite geometry seems to me to be the conversion of angular functions, which in the Indian mathematic had been numbers, in a sense of the word that is hardly accessible to our minds, into periodic functions, and their passage thence into an infinite number realm, in which they become series and not the smallest trace remains of the Euclidean figure. In all parts of that realm, the circle number pi, like the Neperian base epsilon, generates relations of all sorts which obliterate all the old distinctions of geometry, trigonometry, and algebra, which are neither arithmetical nor geometrical in their nature, and in which no one any longer dreams of actually drawing circles or working out powers. At the moment exactly corresponding to that at which, circa 540, the classical soul in the person of Pythagoras discovered its own proper Apollonian number, the measurable magnitude, the Western soul in the persons of Descartes and his generation, Pascal, Fermat, and Desargues, discovered a notion of number that was the child of a passionate Faustian tendency towards the infinite. Number as pure magnitude inherent in the material presentness of things is paralleled by numbers as pure relation, and if we may characterize the classical world, the cosmos, as being based on a deep need of visible limits and composed accordingly as a sum of material things, so we may say that our world picture is an actualizing of an infinite space in which things visible appear very nearly as realities of a lower order, limited in the presence of the illimitable. The symbol of the West is an idea of which no other culture gives even a hint, the idea of function. The function is anything rather than an expansion of. It is complete emancipation from any pre-existent idea of number. With the function, not only the Euclidean geometry, and with it the common human geometry of children and laymen, based on everyday experience, but also the Archimedean arithmetic cease to have any value for the really significant mathematic of Western Europe. Henceforth, this consisted solely in abstract analysis. For classical man, geometry and arithmetic were self-contained and complete sciences of the highest rank, both phenomenal and both concerned with magnitudes that could be drawn or numbered. For us, on the contrary, those things are only practical auxiliaries of daily life. Addition and multiplication, the two classical methods of reckoning magnitudes, have, like their sister geometrical drawing, utterly vanished in the infinity of functional processes. Even the power, which in the beginning denotes numerically a set of multiplications, products of equal magnitudes, is, through the exponential idea, logarithm, and its employment in complex, negative, and fractional forms, disassociated from all connection with magnitude and transferred to a transcendent relational world which the Greeks, knowing only the two positive whole number powers that represent areas and volume, were unable to approach. Think, for instance, of expressions like epsilon to the power of negative x, the pi root of x, and alpha to the power of iota over I. Every one of the significant creations which succeeded one another so rapidly from the Renaissance onwards, imaginary and complex numbers introduced by Cardano as early as 1550, infinite series established theoretically by Newton's great discovery of the binomial theorem in 1666, the differential geometry, the definite integral of Leibniz, the aggregate as a new number unit hinted at even by Descartes, new processes like those of general integrals, the expansion of functions into series and even into infinite series of other functions, is a victory over the popular and sensuous number feeling in us, a victory which the new mathematic had to win in order to make the new world feeling actual. In all history, so far, there is no second example of one culture paying to another culture long extinguished such reverence and submission in matters of science as ours has paid to the classical. It was very long before we found courage to think our proper thought. But though the wish to emulate the classical was constantly present, every step of the attempt took us in reality further away from the imagined ideal. The history of Western knowledge is thus one of progressive emancipation from classical thought, an emancipation never willed but enforced in the depths of the unconscious. And so the development of the new mathematic consists of a long, secret, and finally victorious battle against the notion of magnitude. One result of this classicizing tendency has been to prevent us from finding the new notation proper to our Western number as such. The present-day sign language of mathematics perverts its real content. It is principally owing to that tendency that the belief in numbers as magnitudes still rules today even amongst mathematicians. For is it not the base of all our written notation? But it is not the separate signs, for example, chi, pi, and sigma, serving to express the functions, but the function itself as unit, as element, the variable relation no longer capable of being optically defined, that constitutes the new number. And this new number should have demanded a new notation built up with entire disregard of classical influences. Consider the difference between two equations, if the same word can be used of two such dissimilar things, such as 3 to the power of x plus 4 to the power of x is equal to 5 to the power of x, and x to the power of n plus y to the power of n is equal to z to the power of n, the equation of Fermat's theorem. The first consists of several classical numbers, i.e. magnitudes, but the second is one number of a different sort, veiled by being written down according to Euclidean Archimedean tradition in the identical form of the first. In the first case, the sign equal sign establishes a rigid connection between definite and tangible magnitudes, but in the second it states that within a domain of variable images there exists a relation such that from certain alterations, certain other alterations necessarily follow. The first equation has as its aim the specification by measurement of a concrete magnitude, viz. A result, while the second has in general no result but is simply the picture and sign of a relation which, for n greater than 2, this is the famous Fermat problem, can probably be shown to exclude integers. A Greek mathematician would have found it quite impossible to understand the purport of an operation like this, which was not meant to be worked out. As applied to the letters in Fermat's equation, the notion of the unknown is completely misleading. In the first equation, x is a magnitude, defined and measurable, which it is our business to compute. In the second, the word defined has no meaning at all for x, y, z, n, and consequently, we do not attempt to compute their values. Hence they are not numbers at all in the plastic sense, but signs representing a connection that is destitute of all hallmarks of magnitude, shape, and unique meaning, an infinity of possible positions of like character, an ensemble unified and so attaining existence as a number. The whole equation, though written in our unfortunate notation as a plurality of terms, is actually one single number, x, y, and z, being no more numbers than plus and equals are. In fact, directly the essentially anti-Hellenic idea of the irrationals as introduced, the foundations of the idea of number as concrete and definite collapse. Thenceforward, the series of such numbers is no longer a visible row of increasing discrete numbers capable of plastic embodiment, but a unidimensional continuum in which each cut, in Dedekind's sense, represents a number. Such a number is already difficult to reconcile with classical number, for the classical mathematic knows only one number between 1 and 3, whereas for the Western, the totality of such numbers is an infinite aggregate. But when we introduce further the imaginary square root of -1, or I, and finally the complex numbers, general form a plus bi, the linear continuum is broadened into the highly transcendent form of a number body, i.e. the content of an aggregate of homogeneous elements in which a cut now stands for a number surface containing an infinite aggregate of numbers of a lower potency, for instance all the real numbers, and there remains not a trace of number in the classical and popular sense. These number surfaces, which since Cauchy and Riemann have played an important part in the theory of functions, are pure thought pictures. Even positive irrational number, for example the square root of 2, could be conceived in a sort of negative fashion by classical minds. They had, in fact, enough idea of it to ban it as aratos and alogos. But expressions of the form x plus yi lie beyond every possibility of comprehension by classical thought, whereas it is on the extension of the mathematical laws over the whole region of the complex numbers, within which these laws remain operative, that we have built up the function theory which has at last exhibited the Western mathematic in all purity and unity. Not until that point was reached could this mathematic be unreservedly brought to bear in the parallel sphere of our dynamic Western physics. For the classical mathematic was fitted precisely to its own stereometric world of individual objects, and to static mechanics as developed from Leucippus to Archimedes. The brilliant period of the Baroque mathematic, the counterpart of the Ionian, lies subsequently in the 18th century and extends from the decisive discoveries of Newton and Leibniz through Euler, Lagrange, Laplace, and d'Alembert to Gauss. Once this immense creation found wings, its rise was miraculous. Men hardly dared believe their senses. The age of refined skepticism witnessed the emergence of one seemingly impossible truth after another. Regarding the theory of the differential coefficient, d'Alembert had to say, "Go forward, and faith will come to you." Logic itself seemed to raise objections and to prove foundations fallacious, but the goal was reached. This century was a very carnival of abstract and immaterial thinking, in which the great masters of analysis, and with them Bach, Gluck, Haydn, and Mozart, a small group of rare and deep intellects, reveled in the most refined discoveries and speculations, from which Goethe and Kant remained aloof. And in point of content it is exactly paralleled by the ripest century of the Ionic, the century of Eudoxus and Archytas, 440 to 350 BC. And, we may add, of Phidias, Polycletus, Alcamenes, and the Acropolis buildings, in which the form world of classical mathematics and sculpture displayed the whole fullness of its possibilities, and so ended. And now for the first time it is possible to comprehend in full the elemental opposition of the classical and the Western souls. In the whole panorama of history, innumerable and intense as historical relations are, we find no two things so fundamentally alien to one another as these. And it is because extremes meet, because, it may be, there is some deep common origin behind their divergence, that we find in the Western Faustian soul this yearning effort towards the Apollonian ideal, the only alien ideal which we have loved and, for its power of intensely living in the pure sensuous present, have envied.